Well, in the last video, we learned how to write the recursive formula for arithmetic sequences. Now let's write a recursive formula for geometric sequences. Here's our geometric sequence. A sub n is equal to 4 times 3 to the power of n minus 1. Right? How do we write the recursive formula? Well, what we need to do is we need to define what a sub 1 is. We need to find the first term in the sequence. And we also need to find r. And so r is the base that's taken to the power of n minus 1. Okay? So r is going to be equal to 3 in this case. And then a sub 1, how do we find that? Well, we're going to take our our formula here, and we're going to substitute in 1 for n, right? A sub 1 is equal to 4 times 3 to the power of 1 minus 1, right? N is 1. So we're going to say a sub 1 is equal to 4 times 3 to the power of 1 minus 1. And 1 minus 1 is equal to 0, so it's 4 times 3 to the power of 0. And we know that any number to any base to the power of 0 is equal to 1, so it's equal to 4 then, right? Because we have 4 times 1 is equal to 4. So a sub 1 is equal to 4, and r is equal to 3. So knowing that, what can we do? Well, we can go ahead and substitute into our recursive formula here, right? So we're going to go and substitute in 3, and we're going to say a sub 1 is equal to 4 because you need the first term in the sequence. And we're going to say our recursive formula is a sub n. We're plugging into our recursive formula here. A sub n is equal to r. Instead of r, we're going to place a 3 here times a sub n minus 1. And we're done. We always need to put the caveat that this only works for n greater than or equal to 2. Right. So let's go ahead and try that in this example here. Let's first identify our r. Our r here is going to be the base that's taken to the power of n minus 1. So in this case, r is equal to 2. We also need to have our a sub 1. So our a sub 1 is equal to 15 times 2 to the power of 1 minus 1. And again, we have a power of 0 here. Right? So it's going to equal to 15 times 2 to the power of 0. And that's just equal to 15. Right? Because any base to the power of 0 is equal to 1, so it's equal to 15. So we have r is equal to 2, a sub 1 is equal to 15, and we can write our recursive formula for this geometric series. We could say a sub 1 is equal to 15, comma, a sub n is equal to r, which is 2, times a sub n minus 1. And then we need to put the caveat that n must be greater than or equal to 2. And we are done here. So let's put a box around that. And that's that.